but the propeller goes to some 3 meters above the ground.
Now, due to interactions with the ground, there is a wind gradient. Wind travels slower, close to the ground, and then faster higher up. Now, Alex estimated that the wind speed at the propeller might be 10 or 15% higher than at the telltale. So it's possible that the car could be moving slower than the wind at the propeller, and yet appear to be moving faster than the wind at the height of the telltale.
Now, I think 0.8 factor will come in.
So what about the treadmill tests? These are conducted in still air. By moving the ground backwards, you're simulating a perfectly steady tailwind. And if you hold the car stationary on the treadmill, well, that's equivalent to the car going exactly wind speed. Now, if the car can move forward on the treadmill, that shows it can accelerate faster than the wind. But Alex had multiple explanations why these experiments don't actually show what they claim to show.
If you have
Run by MIT aero professor Mark Drella. But here too he found problems. His main concern is that the equation for net force includes the difference between the speeds of the car and the wind in the denominator, which seems to replicate the treadmill experiments. For the first video, I asked my friend and YouTube maker Zyla Foxland to make a model downwind cart. Oh no! Version 1 ended in failure, but Zyla was undeterred, coming back in a couple days with version 2. Is it feeling like it's gonna... Unlike these models, most of her projects actually work. She is determined. So maybe this tells us something about whether you can actually go faster than the wind downwind. What was clear to me is that in 1969, Andrew Bauer built the first successful downwind cart, and he did it to settle a friendly wager with aero engineer Apollo Smith. The bet was inspired by a claim in a student's paper from 20 years earlier. Now, Rick Cavallaro, the builder of Blackbird, was completely unaware of all this until after he built his cart. But other analyses have been published under names like the Push Me, Pull You boat. So I didn't honestly think anyone would doubt the vehicle's operation, much less bet me $10,000. But clearly there is a need for a deeper explanation. So I want to do that now by responding to the points Alex raised. So first, let's deal with wind gradient. I mean, why didn't we measure the speed of the wind higher up? Well, the answer is because it's already been done. They mounted telltales on fishing poles out to the sides of the propeller and even above it. Now, although the lowest telltale flips back first, all of the telltales do eventually flip backwards, showing that every part of the vehicle is going faster than the wind. Could this be because of a big wind gust that pushed the car up to high speed and then the wind died? I don't think so. Even though I didn't have a speedometer in the car for my runs, someone on Twitter pointed out that we could use the rotation of the back wheel to determine the speed from the video footage. This shows that even after the telltale flips backwards, the car keeps accelerating. Another thing I want to point out is that if wind gradient or gusts were the reason that the car travels faster than the wind, well, you'd expect the telltale to jump around or at least not point straight back at me. But it consistently does for over 30 seconds until I had to hit the brakes to avoid crashing into parked vehicles. But if that's not enough for you, when Blackbird achieved its record speed of 27.7 miles per hour in a 10 mile per hour tailwind, it was still accelerating. And we know this because there were multiple GPS units in the car and wind speeds which were measured at the height of the propeller at multiple locations. The highlighted section shows the 10-second measurement period over which the record was set. Not even the professor can doubt what's going on. The first thing to know is that the propeller doesn't work like most people think. It's not working like a windmill. It doesn't turn the way the tailwind is pushing it. Instead, it turns in the opposite direction, working like a fan to push air backwards. This fan is powered by the wheels, which are connected to the propeller by a bike chain. So at wind speed, the car can keep accelerating because the wheels turn the fan, which blows air back, generating forward thrust. Now the big question is, to drive the fan, there must be a backwards force on the wheels, which tends to slow them down. So why isn't this force bigger than the thrust from the propeller, causing the car to slow down overall? Well, the answer is the wheels are going so much faster over the ground than the propeller is moving through the air, so the thrust force can actually be larger. I'm going to do an analysis in the frame of reference of the car, and the important equation to know is power equals force times velocity. So at the wheels, Power is input into the system by the ground moving underneath the car. The power generated is the force of the ground on the wheels times the velocity of the car. At the propeller, work is done on the air as the propeller pushes it backwards. The power out equals the force of the prop on the air times the speed of the car minus the speed of the wind. The prop is going slower through the air due to the tailwind, and if we assume no losses, then the power in at the wheels equals the power out at the propeller. From this equation, we can see that the force at the propeller will be greater than the force at the wheels. And since the propeller is pushing air back, the air applies an equal and opposite force forward on the prop. This is the thrust force, which will be greater than the backwards force on the wheels. So this car, but now we've run into the divide by zero problem that Professor Kosenko warned us about. When the speed of the car is exactly equal to the speed of the wind, it seems like the propeller can provide infinite force. That can't be right, can it? I mean, is our analysis flawed? The answer is no, for two reasons. A model downwind cart. I told you Zyla was determined. Yeah, I'm gonna make the claim on camera. I think it's gonna work this time. We're changing the propeller.
It has to work before we get kicked out of the treadmill store.
Does it work?
It totally works.
Amazing.
Oh my god, it's so good.
Her fourth version of the cart works spectacularly, and it was designed to be replicated by anyone using just a 3D printer and a simple list of materials. She explains how to build it with more details on the engineering process on a video over on her channel, so go check it out. Now, Professor Kosenko has now conceded the bet, and he transferred $10,000 to me. So I want to thank him for being a man of honor and changing his mind in light of the evidence I presented, which is really not easy to do, especially in a public debate like this one. Now,